Well, welcome to the Fat Characterization Lab, and today Rachel and I are going to film the procedures that you're going to be using in lab next week. And we are in chapter 22, Fat Characterization, and there are 4 procedures we're going to film. The first one will be saponification, and then the second one iodine, and the iodine value, which is and then free fatty acid, and then we will be looking at peroxide value of a series of oils that have been oxidized for different lengths of time. So we're going to start with saponification, and I'm going to prepare only one blank and one sample. You will, of course, prepare duplicates of the blank and duplicates of the sample. The procedure is 22.2, and there is a little bit of a method change, and we will be skipping step 1, and we're going to begin by weighing out 5 grams of fat or oil. I'm going to do the demonstration today with canola oil. That will be one of them, but there will be 2 fats that will require some melting. You won't have to do any filtration, you'll just have to melt both coconut and lard. So the first thing to do is I'm going to pour a little bit of my oil into this beaker so that I can actually transfer some. Okay? And then I am going to take my flask, my 1 wrap oil flask, and I'm going to go over to the balance, and it says 5 grams. And I'm going to tear out the weight of my flask. And if you look at this balance, it says 500 ml round bottom flask. There's a balance on each of these benches that you can actually tear out that weight. If you try to use the second balance that's on each bench for 500 mils, you will overweight the balance. I don't know if that's correctly. So I'll tear out that weight, and then I'm just going to add 5 mils to it. 5 grams, excuse me. And then of course I want to try to add it directly to the bottom. Now if I get 4.9 or 5 point whatever, I'm okay with that as long as I know the exact weight, because everything will be on a weight basis. Yeah, I think we're going to go with 5.1154. 1154. And I've written it under saponification in my manual, and then you would have a weight for B. So now it tells you, the next step it says is to accurately add 50 mils of alcoholic potassium hydroxide. And you're going to cross out from a burette, and we're going to just use a graduated cylinder. We only need, this works fine, and so here I have alcoholic potassium hydroxide, and I'm just going to measure out 50 mils. And then I'll do the same for my blank. So my blank doesn't have any oil in it. And that's pretty obvious because I can see that this is cloudy. Close the top, put it in here. Always label what you're doing so that you know what you actually have, because it will actually look different when it's done. The fat will clarify. So the next step it tells you to do is, I just prepared the 50 mils with the blank, and now I'm going to add several boiling beads, and I'm going to connect it to what's called a dry condenser. So we'll take this over to the hood where our condenser is. So this is ethanol. When you prepared your samples for fat extraction using sock flint, you actually use petroleum ether And petroleum ether boils at like 34 degrees. And ethanol boils at, I believe, about 75. I looked it up. So I have turned the heat on already, and I'm hoping that I'm not too far off. But when you set your flask up, what I want you to do is stay here, whoever's doing this, until you actually see your ethanol boiling. So I've got my water turned on, and I set it up correctly this time. And I'm going to just put my clamp on. And you know how to do this, because you should be able to do this on your own. I'm going to turn my heat down. It feels a little hot. And then I'm going to just loosen one of these screws. And I'm going to drop this down so it's sitting in the heating mantle. I'm going to do the same for this one. Okay, so now I'm just going to stay here until I have a boiling ethanol solution. And then I will start my timer, and I'm going to allow the saponification. Remember, this is where we are breaking the glycerol backbone from the fatty acids so that we can determine the saponification value. Okay, so now I can see that my ethanol is boiling. And I just wanted to point out that this should look different to your eye if you remember from the condenser you saw before. This is called an air condenser. So it has water on the outside sleeve, and then it's just an open column of air. The reason I point that out is as it boils, the vapors come up, they hit the cold water, then they drip back down, okay? So what you want to do when it's all done is you'll turn off the heat, or we'll lift the flask, and then you'll take a squirt bottle of water and you'll just kind of squirt the inside of this tube down. It says to do that in your instructions. So now I'll set my timer and we'll just let this go for 30 minutes. So my 30 minutes of saponification is finished, and so now what I'm going to do is lift this whole unit. I'm going to loosen one of these screws and lift the whole thing off the heat, because it has to cool off a bit before I can do anything with it. So I'll do that to both my sample, which is now nice and clear, but it has a yellow cast to it, and also the blank. And then remember I said you need to wash the inside of the air condenser off. So then I'm just now going to just take my squirt bottle of water, not ethanol, and I'm just going to rinse the inside. Then anything that's on the inside of that wall will get rinsed back into that flask. Then I'll do the same thing to this one. And then I'm just going to give it maybe about 5-10 minutes for it to cool off, and then we'll proceed with the titration. So now we are finished with the saponification. So we should have free fatty acids, and we should have glycerol backbones. This is my canola, and this is my blank. Now I'm going to do the titration, and I'm going to use an indicator, a phenolphthalein indicator. And the titration is with standardized HCl, and you're going to want to write this down because this is part of the equation when you calculate the saponification value. Okay, and it's 0.50819. And I believe it's the same HCl. No, Rachel standardized this. Okay, so again, you remember you need to rinse out the burette first with one volume. So I'm going to make sure I close the stopcock. And if you're a short person and you have a tall partner, maybe ask for some help. And then I'm going to waste this into this beaker. You only need to do this once. And remember, when I fill it again, I want to make sure that I have solution down in the tip of the burette, so that when I'm titrating, that I am not titrating. So I've already added acid up to here. So now I'm going to bring it up to 0, and I'm actually going above 0 because I need to displace that air volume that's there down at the bottom from when I drained it. And so I just want to watch I can see the air going away. Rachel taught me this. And then I'm going to keep going till I get to 0. Make sure you're careful with the stopcock, because if you pull it at all, you'll get a leak. And now I need to add some more acid back in. So now I'm ready to titrate. Okay, so I'm going to give you a hint. We're using a 50 mil Dirac, and the reason why is because this is going to take a lot of volume. So the first thing we're going to do is put our cap back on, and then we're going to add 1 mil. It says to add 1 mil of phenolphthalein to each of your solutions. So remember, the phenolphthalein is shows up pink right around neutral pH, or when it's basic, it is quite pink, and then as it gets closer to neutral, it turns a light pink. Okay, you can see, isn't that beautiful? This is actually kind of a pretty lab. You can see. So remember, I started out with an alcohol of potassium hydroxide, which is a base. And so now I have a very basic solution, and I'm going to titrate with an acid. Okay. Okay, so I need to actually raise this up a bit. And I'm going to start with the blank, and I am going to tell you that it takes a lot of volume. So I'm going to just titrate, and you can see nothing's going to happen, nothing's going to happen. And if you think about it, it kind of makes sense, because I used a base that was reasonably strong. I don't remember what the concentration is. It says in your lab manual. And it's still quite pink, and I've used 8 mils. And I will tell you that the blank takes close to 60. So what I will do is just keep going and swirling. Just because I said that doesn't mean you need to believe me. But I'll watch my volume, and I'll look for any lightning. And chances are I'll get to 50, and I'll have to refill. So this is a different titration. We start with color, and we're titrating to almost no color. Okay, so I'm approaching 50, and I'm still quite pink. And I want to stop at 50. I don't want to empty it, even though I could, because I need to know how much volume I actually added. So I stopped. Okay, we're still pink, so that's not going to work. So then we add more. I'm ready to go again. Oh my goodness. I looked up just like that, and it changed. So you can see it's rather dramatic when it does it. And I probably just over-titrated. So I have 59 mils here for my blank. Okay? Actually, it says you're going to titrate until the pink color just disappears. So we're going to accept that. So you can see that the pink color has just disappeared. So you would write down 59 mils for your blank. Okay? So now I'm going to do the same thing for my sample. Okay, so now I'm ready to titrate my canola, my oil sample. And remember, the blank took 59 mils. I can tell you that this will not take 59 mils. Okay, there we go. There it went, just like that. So that looks pretty good. And so I dispensed 25 mils. So I'll write down 25 mils for my volume there, and I will also record it in the spreadsheet for the calculation. So I have the normality and the volume and the weight of the sample. Those are all part of the calculation that is shown right there. Okay, so it's your blank minus your sample volume times the normality times 56.1. 56.1 is the molar weight, molecular weight of KOH, divided by the weight of your sample, and that gives you your saponification value. Now I'm going to show you how to prepare your sample to determine the iodine value, and that is going to be procedure 22.31, and you can read the objectives. There is a modification that you want to write in your lab manual. We're going to skip step 1, and then instead of 0.1 to 0.5 grams, we're going to use 0.25 to 0.3 grams. So this is quite a bit less fat than we use for preparing the saponification. And we're going to use these 500 ml volumetric flasks with stoppers, not stoppers. And what I'm going to do is just prepare one sample and one blank. And then you, of course, will do it in duplicate. So again, I will go over to the balance. And I'm going to tear out the weight using, this is for the 500 ml round bottom. I'm going to tear out that weight. Okay, so I have just teared out the weight of my flask. Now, if you're having a problem getting a stable rate reading, let either myself or one of the TAs know, because it's probably due to a static charge. So I said I wanted
0.25 to 0.3.
Thank you. So I want to weigh out 0.25 to 0.3 grams. Okay, I'm going to close the door, and then I'm going to record that weight. It's 0.2899 in my lab manual. You'll put this in your lab notebook. And this is all going to go into a spreadsheet like you've used before. So I'm ready to proceed forward. So I took my gloves off to do this because of the charge. If you do that, be sure and wash your hands to get rid of any oils. So I'm going to go back and then I'm going to check my procedure. And I'm going to put some fresh gloves on for the rest of the procedure, because I'm going to be working with some toxic compounds. And so the first thing that we are going to do is we're going to go over to the hood, and in the hood is we are going to add 10 mils of chloroform to the oil or the fat. So I have set up a bottle with chloroform over there and a 10 ml pipette, I believe. So go over to the hood. Chloroform is actually one of the compounds, one of the solvents that you really want to avoid inhaling. So you always want to work with it if you can in the hood. Turn on the light, and I have a pipette here. I'm going to add 10 mils to each one. And remember, this is a to-deliver pipette. You don't need to blow out any volume on this. So I'm going to just swirl this around to make sure that it's nice and solubilized. And the next step that your procedure tells you to do is add 25 mils of this reagent. So the next step in your procedure is to add 25 mils of this solution. It's called WISH reagent. If you can buy it from Fisher, it's called iodine solution. Okay, put that on, I'm going to swirl it around. And now what it tells you to do is to take your flasks back to your workspace, and you're just going to put them in the dark. Okay? So it says that you're going to add your whisk solution and then let the flask stand for 30 minutes in the dark with an occasional shaking. So I'm going to just find a cabinet, stick them in there. Close the door. Okay, so here are my flasks that have been incubating in the dark for 30 minutes, and then they were swirled periodically. So now I'm ready to finish the sample prep and then do the titration. So the first thing it says to do is to add 20 mils of 15% potassium iodide. I'm just going to use a graduated cylinder. Now this is water that's been boiled because it tells you to use 100 mils of freshly boiled water, and it says to wash the inside down with that. So now I'm ready for my titration. So this titration, what's going to happen with this is that you're going to titrate the iodine with standardized 0.1 normal sodium thiosulfate. There's another titration you're going to do that uses sodium thiosulfate, but this one uses 0.1 normal. And it says that as you're titrating it, it will, you keep shaking until the yellow color almost disappears. And then you're going to add 1 to 2 mils of starch indicator, and that's going to, it kind of like expands the titration color window, and then you keep titrating until towards the end of the titration, and then you stopper the flask and shake violently so that any iodine remaining in the chloroform can be taken up by the potassium iodide. Okay, so this is the burette you're going to use, and I've already added the 0.1 normal sodium thiosulfate, and I think you needed to see that again because you know how to do that. And so I'm going to start by titrating the blank. But what I'm aiming for is for this color to start disappearing and then turning a yellow. And then at that point, I'm actually going to add some indicator, starch indicator, which will darken it some. At this point, I'm going to actually add the starch indicator, like Rachel just suggested. And I'm just going to add probably a mil to it. You can see how nice and dark it made it. So I think a mil is definitely enough. Now, it does not look blue like your lab manual says. It's really more of a purpley color. Look at that, isn't that beautiful? So this is like 50.8 mils is what it took. And it says to put the stopper on and shake it vigorously at this point. It says shake violently so that any iodine remaining in the chloroform can be taken up by the potassium. And I think I'm going to add one more drop here, because I can get the stopper out. Make sure you have your gloves on. So we are at 51 mils for our blank. So we're going to write that down for the blank. And then that, of course, will go into the spreadsheet for your calculations. Now you'll do the same thing for your sample. Okay, I think I'm ready to add starch. So I'm going to add a ml of my starch solution. And right now I've titrated like 20.5 mils. You can see I've got a nice purple color. It looks like something from the deep sea. And that might have done it. 26.2. We're going to go with 26.2. And that was it. So that's iodine value. So now I'm going to write that down. So that took 26.2 mils. I'll put that into the spreadsheet along with the normality of my sodium thiosulfate, which was 0.1 normal, and then complete the calculation. The next procedure that we're going to demonstrate is to determine free fatty acid in your oil. And this uses a neutralized ethanol. And then you're going to use a standardized base. So you're going to want to write that down. And then you'll do a titration to color. You're also going to use an indicator, the phenolphthalein. You used it before in the motion A extraction if you were a cheese sample, you saw it. Okay, so your procedure says to prepare 4 flasks. There is not a blank, no blank for this method. The 4th flask, one of the flasks it says to use is just to practice. And then the other 3 flasks are for your samples. This titration does not take much volume at all, and so I think that's why it has you practice with 1 flask, so you get a sense of what you might expect. So I'm going to label my flask, and it's going to be canola A, and then I'm going to go over, and it says to weigh 5 grams. So I'll take them over to my balance again. So I'm going to weigh out 5 grams to put in there. So I have weighed out my 2 flasks of about 5 grams of oil, and I'm going to bring it back over to the station that's set up for free fatty acids. And I've written down my numbers. And the instructions say that you are going to add 100 mils of neutralized ethanol and 2 mils of phenolphthalein. So I have my neutralized methanol here. Small amount, I'm afraid I always overpour when I use a funnel. Okay. Okay, so if you look at this ethanol, it's a 95% and it has a very slight peak cast. And that is approximately the color you're aiming for, if you can see it. But I'm going to add 100 mils. For those of you that are using, that are analyzing coconut and lard, as soon as you add your ethanol, you will probably end up, it'll drive it out of solution, because it'll be solid at that temperature. But you'll just keep swirling, and the free fatty acids, if there are some, will go into solution. So, okay. So I've got that. Now I'm going to add 2 mils of my phenolphthalein with a pipette that's actually orange here. I have it set at 1.00. You each have a little container. It says FFA for free fatty acid, and it says phenolphthalein. Pre-wet the tip always. And I'm going to just add 2 1 ml volume.